Hi, today I am going to discuss a concept on linear data structure, Q. So starting with the aim of the session is to learn the concept of linear data structure Q and its operation. So what is the instructional objective? That is, the session is designed to define the Q data structure and also to understand all the operations used in Q concept. And what is the learning outcome? So at the end of this session, we should be able to implement various operations of Q data structure. Now starting with the introduction. So you should know, like, Q is a linear data structure which has two ends known as front and rear. Q as follows a separate mechanism, that is FI FO. We say it as first in first out mechanism. In order to perform the Q operation, we have to use front end to delete an element from the Q, and also rear end is used to insert an element from the Q. So consider this example, an array which with a value A, B, C, D, E, where front is pointing to the starting array value and rear is pointing to the last array value. So here I should not say it as an array, we should say it as a Q. Here insertion of an element in the Q is known as NQ operation. Deletion of an element from the Q is known as DQ operation. Here NQ operation can be performed only at the rear end. DQ operation can be performed through front end. Initially both front and rear value is -1, and also be very clear, this front and rear are variable which points only to the Q index numbers. When an element is inserted at the first time, both ends are set to 0. It means like both front value and rear value should be assigned to 0. For every insertion of an element, be very clear, rear end is incremented by 1 up to size -1. Size is nothing but the maximum size of the Q, -1. After that we should not increment the rear. If for every DQ operation front end is incremented by 1 up to rear, so we have to increment the front each and every time by 1 up till only till the rear value. So that we have to check some condition, that is, if front is greater than rear, every time Q is empty. And also if front is equal to 0 and rear is equal to size -1, be very clear that the Q is full. Here we are going to discuss about the algorithm for NQ operation as well as DQ operation. Keep in mind that if I need to insert a value into a Q, we need to perform NQ operation. If I need to delete a value from the Q, we need to perform DQ operation. So here is the algorithm for NQ operation. That is, initially you have to start the process. If I read an element from the user in the variable called value, the first condition what we have to check here is, we have to check whether rear is equal to size -1. If rear is equal to size -1, if rear value is equal to size -1, it means like the Q is full. It means further we cannot NQ any value into the Q. If not, we check another condition, that is, if both front and rear value is -1, it means that there is no element in the Q. So that we have to set both front and rear value as 0, and after setting the front value and rear value as 0, we have to assign the input value to the Q array. Otherwise, what is that we have to do? Simply increment the rear value by 1 and assign the input value in the Q and stop the process. Here, in case if I need to perform a DQ operation, or else if I need to delete an element from the Q, what is that we have to do? Here is the algorithm. That is, initially we are starting the process. What is the initial condition we need to check here? That is, if front is equal to -1, or in case if my front value is greater than rear, what is that? We print Q is empty. It means like there is no element in the Q. If there is no element in the Q, there is no need of deleting a value. In case that if there are some elements in the Q, what is that we have to do? Directly the Q value the element what we are supposed to delete, that value is assigned to a variable called element. As already I said, if we need to dequeue an element from the queue, we have to increment the front value by 1. So increment the front value by 1 and we display the element which is being deleted. So further, in case if you want to delete any value from the queue, we have to repeat the process until there is no element in the queue. Finally, we stop the process. So this is very important operations in queue, that is enqueue operation and dequeue operation. Here a small example we are going to discuss how an enqueue operation has to be done and how a dequeue operation can be done with some sample inputs. That is, consider initially I am taking a max variable, size is 5, and also a queue array with max value size. Initially we said like front value and rear value should be -1, all are integer values. I am just considering an integer array. Okay, first of all, my integer array, that is my queue array is integer, that is why my queue array integer I am going to take here. So initially I don't have any value in the queue, so that front and rear value should be -1, indicates my queue is empty. Now what is the task I am going to do here? So what is the example I am going to discuss here is, I am just taking value 10, 20, 30, 40 and 50. These 5 elements are to be enqueued in the queue. So for that, what is the steps we have to follow? As I explained the algorithm before, initially there is no any element in the queue. If there is no any element in the queue, front and rear is -1. Now I need to enqueue the value 10 into the queue. So what is that we have to do first? Here first of all we have to increment the front value and rear value by 1, so that my front value is 0 and rear value is 0. Once front and rear is pointing to the starting index 0, now we are enqueuing the value 10 into the queue. This is step number 1. Value 10 is being enqueued into the queue. Next, now what is step number 2? My second value has to be enqueued. So be very clear, if further values have to be enqueued, so each and every time we should not touch the front, we have to each and every time increment the rear value by 1. So in order to enqueue the queue value 20, first rear has been incremented, so from 0 rear will be pointing to index value 1. So once if rear value is incremented, now we are enqueuing the value 20 into the queue. Same way in step number 3, next value what we need to enqueue is 30. Now what we are supposed to do? Further we have to increment the rear value by 1. So once after the rear value is incremented, my rear value becomes 1. So now the value 30 is being enqueued. Now next, my step number 4, we have to enqueue 40 here. So again we are incrementing the rear value by 1. Now my rear value is 3. Once after incrementing the rear value, we are enqueuing the value 40 into the queue. Next, the last value is 50. Now further we are incrementing the rear value. My rear value is 4. After incrementing the rear value, my input value is being enqueued into the queue. Now in case, here be very clear what is my queue size. Already we have set the queue size as 5. It means my array size, last index will be size -1, which is nothing but 5 minus 1 is 4. Say I need to further enqueue a value into the queue. So is it possible? It is a big question here. So be very clear. First of all, if my queue size is 5, we cannot further enqueue any element more than 5. So for that we have to set a condition here first, that is initially we check whether your rear value is equal to your max -1. Max value is 5 here. As of now your rear value is 4. So 4 double equal to 5 minus 1. If this condition is true, we say that the queue is overflow. If queue is overflow, it means we cannot further enqueue any element into the queue. So this is a very important condition for overflow condition. So this is what about enqueuing elements into the queue. Same way, Here I discuss an example to dequeue some elements from the queue. So in continuation to the previous queue, my queue contains 5 elements. So with same 5 elements, my front value is pointing to 0th index, my rear value is pointing to last index. So now I need to dequeue all the elements from the queue. So step number 1, I am dequeuing value 10. So dequeue, in the sense, be very clear, dequeue should happen only in the front side. Okay, that is starting from 0th index. So if I need to dequeue a value, we have to increment the front value by 1. So from 0, front is incremented by 1, so front move to 1. So it means like the current 0th index value is being dequeued. Same way, if I need to dequeue the value 20 here, further we increment the front value by 1. So my front value will be 2. So value 20 is being dequeued. Same way, if I need to dequeue value 30 from the queue, further increment the front value by 1. So my front value will be 3, value dequeued will be 30. Similarly, I need to dequeue 40, value 40 is being dequeued from here. Once if value 40 is being dequeued here, be very clear, rear front value is being incremented. So once the front value is being incremented, my front and rear points to the same index. Now what is my last step here? I have only one element in the queue where front and rear is pointing to the same index. I need to dequeue one element from the queue. So if I dequeue this particular element, what happens here? My front will be incremented. If I increment my front value will be greater than the rear. If that is the case, what is that we have to do? So be very clear, once if your front value is greater than the rear value, it means like there is no elements in the queue. So here we set a condition here, if front and rear both are same, there is one assignment to be done, that is rear value is -1 and front value is -1. As initially what I said here, if front value and rear value is -1, it means that the queue is empty. So this condition is to be checked here. When my front and rear is pointing to the same index, if we need to perform a dequeue operation, be very clear, we can say that we can assign front and rear value as -1. Further, once after front and rear value, be here in the last queue here, there is no any element in this particular queue. If I need to delete any value from this particular queue, here already my front value and rear value is -1. So further we cannot delete any value from this queue, so that it goes for an underflow condition. Since it is an underflow condition, be very clear when an overflow condition will happen and when an underflow condition will happen. So with this, the overflow condition is if rear value is max -1, as well as for underflow condition my front and rear value will be -1. So with this, both the operations are very important. Here there are some of the terminal questions what you should be able to answer once if both enqueue operation and dequeue operation is being successfully done. That is, you should know what is a queue, what is a front, and as well as what is a rear, and also you should be able to define the queue using arrays. With this, you can note down the reference book which has been suitable for referring linear data structures, and also thank you for the session.